Hey everyone, this is Sean McCord, and this is my project on cryptography learning for my capstone. Um, I wanted to start off with a project overview. My goal is to implement various encryption algorithms as a learning tool in C Sharp. My target audience are future students trying to get into or just learning cryptography in college. Uh, and my general goal is to provide a deeper understanding of how these algorithms work and to compare them against each other under different circumstances. The reason for this is, for a lot of different classes and certifications, these algorithms are very important for, getting certifications, passing classes, and just generally understanding it within the computer science field. I plan on implementing the DS, AES, ECC, RSA, and Diffie-Hellman algorithms within my project, and I also want to provide a means to compare these algorithms against each other. So, like I was saying earlier, my general project motivations are related to the importance of cryptographic algorithms within computer science classes. At Morehead State University, especially, I know that cryptographic algorithms are important in computer security classes, network security classes, computer architecture, advanced algorithm and data structures. It's generally just good to know how these algorithms work. So, having a centralized project where users will be able to test these algorithms themselves and get hands on with it I think will be really beneficial for students. Another big thing is certificate-based programs focus heavily on encryption algorithms. Um, for example, the CompTIA based certificates like Security Plus, Network Plus, A Plus, um, these all have pretty big focuses on encryption algorithms, especially Security Plus. I personally took the Security Plus 601 test. I want to say 6 months ago, and that exam focused hard on encryption algorithms like the data encryption standard and advanced encryption standard. So, learning how to get hands-on with these different algorithms will be beneficial for future students trying to get these certificates or pass these different classes that have a heavy focus on them. And just in general get a deeper understanding of how these encryption algorithms work and just generally encryption as a student. And another motivation is I kind of wanted to see how these algorithms stack up against each other under different circumstances. I know that some algorithms are slower than others, and some have worse performance for some various reasons like security. So, for example, DS is known to be slower than AES because it's an older algorithm made in 1970 versus 2000. So, this is a list of the algorithms I plan to implement in my project. I wanted to start off with the data encryption standard. It's a symmetric key algorithm that encrypts data in 64-bit blocks using a 56-bit key. This algorithm was originally made in the 70s, and it was actually a standard by the US government up until around 2001. And as our computers have gotten better, a 56-bit key is pretty small. So, people trying to brute force guess this key will be able to do that a lot faster using today's computers than they could back in the 70s. And for this reason, it was eventually replaced by the advanced encryption standard. This is another symmetric key algorithm that encrypts data in 128-bit blocks instead of 64-bit blocks, and it supports varying key sizes of 128 bits, 192 bits, or 256 bits. A big thing about this algorithm is that it has a larger key size than DES, and that was a big upgrade from DES. And this algorithm is actually still the standard used by the U.S. government because this larger key size and difference in algorithms just make it so much stronger against brute force attacks. And its difference in the way that it actually encrypts and decrypts makes it stronger against analytic attacks as well. Another encryption algorithm I plan to implement is called elliptic curve cryptography. This is a little bit different than the previous two because it is a public key cryptography algorithm, and it uses elliptic curves to generate the uh, the public and private keys. It uses the mathematic structure of elliptic curves to generate these keys. And for my project, I haven't gotten into researching these two as much. I've spent a lot of time these past couple weeks on DES and AES, but my future plan is to continue researching these different algorithms and learn more about them. Another algorithm that I plan to implement is called RSA. This is another public key cryptography algorithm, and this one relies on the difficulty of factoring large integers. I haven't gotten around to researching this one either. And another algorithm I'm planning to implement, but might I'm not sure how this one will turn out. It's called Diffie-Hellman. This is a key exchange protocol, so it's a little bit different than an encryption algorithm because this one is actually used to share keys between different people rather than encrypt some message. So I've still got to research those last three. I've spent the last couple weeks on DES and AES, but future plans are to get there. So these past couple weeks, whenever I first started on my project, I wanted to get a list of functional requirements together. Starting off, I wanted to make my project in C sharp. This is for a couple different reasons, but the main two are the Windows Forms user interface. I'm familiar with programming Windows Forms, so I wanted to use a user interface related to that. And another reason is that C-based languages are pretty good for programming encryption algorithms. That's just because of the way the languages themselves are built and the different libraries that are built into like C++ and C sharp make it a little bit easier to build these encryption algorithms out. Another requirement is I wanted to at least have AES and DES encryption implemented. Uh, Whenever I made this list, I wasn't entirely sure how complex these algorithms were going to be. And, as I've researched them, they're pretty complex. So I wanted to at least get on paper that I would have AES and DES encryption within my project. I still plan to have, elliptic curve cryptography, RSA, and Diffie-Hellman if I can, but I wanted to have a minimum of AES and DES encryption. Another functional requirement is the algorithm speed measurement. I want to be able to compare these algorithms' speed against each other. Because, in class, we always learn how AES is better than DES and it's faster. But I wanted to actually prove that and, get hands on with that for future students. This one's kind of a given, but I want users to be able to encrypt their own text files. And I want these text files to be, of any size. Users can upload their own text files and, they'll get an encrypted file back. And this encrypted file, I want to have an explanation of the algorithm that they chose to use in that returned file. That way, people who use this program will have a explanation on what exactly happened for their data to be transformed into the ciphertext. and this one's a given, but I wrote it down anyway. The decryption functionality. So if users uploaded a encrypted file and they decrypt it with the algorithm with the correct algorithm, it will return their plain text back to them. And the last one is potentially I plan to improve these different algorithms where I can. For example, DES has a small key size, and that's one of the main issues with it is the 56-bit key is really easy to crack with modern computers. So one example of an improvement would be to increase the key size for DES, or maybe improve on the encryption decryption functionality of different algorithms where I can. So here I wanted to talk a little bit about my current progress. So far I've been researching the DES and AES block ciphers, and as part of a, proof of concept, I worked to complete the tiny encryption algorithm in C++. So the tiny encryption algorithm is very similar to DES and AES because it's another type of block cipher, and it was really useful, or it was really helpful to learn how to program a block cipher in C++. C Sharp and C++ are very similar, and the tiny encryption algorithm works very similarly to DES. They both use a Feistel function for their encryption and decryption process. So it was really interesting to be able to program that. There are some potential difficulties I wanted to go over. Um, Encryption algorithms are very complex and take time to figure out their complexities. For example, AES and DES both use really complex matrix operations like shifting and stuff like that. And it takes some time to figure this stuff out. So, you know, it could be a problem um, because of how complex these functions are. But I I plan to research as best as I can. Another problem is public key encryption algorithms like elliptic curve cryptography are a lot different from the block ciphers that I've become used to, like the advanced encryption standard and data encryption standard, and the tiny encryption algorithm as well was also a block cipher. So learning how to use public key encryption algorithms will be a lot more challenging, I believe, than the block ciphers. Another potential difficulty is that the data type transformations for encryption are pretty difficult to understand. So, what I mean by this is, for example, whenever I was programming the tiny encryption algorithm, you had to use a lot of bitwise shifts and whatnot to control the data types that you needed when you needed them. So, for example, you had to take your string, transform it into an unsigned integer, and then transform the unsigned integer into a hexadecimal for encryption. And for decryption, you had to do the opposite. And it was kind of difficult getting used to the bitwise operators needed to perform this. And that leads us into the next point that encrypting the or implementing these algorithms will take a lot of trial and error. So it'll probably take some time to get everything working. And that's the general idea of this slide is it'll take some time to get everything working. Here I wanted to talk about current cryptography trends. Uh, a lot of focus in the industry has been on post-quantum cryptography. Uh, and basically what this means is the increased processing ability of quantum computers have made it to where brute forcing different encryption algorithms has been easier than ever. So uh, a lot of different industries and groups are concerned with how to deal with the improvement of processing power related to quantum computers and how to make encryption algorithms that are resistant to brute force attacks from quantum computing. Another trend has been in homomorphic encryption. And basically, what this is allowing operations to be performed on encrypted data. So, for example, like your bank account information could uh, have operations performed on it while it's still in its encrypted form. That way, there's no point where it becomes decrypted and vulnerable. And of course, there are ongoing standardization and regulation efforts from the National Institute and Standards of Technology to increase security related to encryption, um, similar to the post quantum cryptography mentioned above. So, for future work, I plan to continue researching these different algorithms, mainly the public key encryption algorithms like elliptic curve cryptography, RSA, and Diffie-Hellman. Um, I also plan to implement a data encryption standard demo program in C Sharp. That way, whenever it comes time to actually implement my project, I'll already have some of the encryption algorithms complete. That way, I can reuse some of that code later on. I also plan to refresh myself with C Sharp Windows Form programming in Visual Studio. It's been probably 2 years since I've, done a whole lot with Windows Forms, so it'll be nice to catch back up on how to use everything. I also plan to create a software requirement specification document and some dependency diagrams just to further define my project. Uh, but yeah, that's what I plan for the future. So I just wanted to say thank you. Thanks to my advisor for helping me out with my project, and I'll update you next time.